All right, it's time. Welcome to Swagelok Helsinki, Swagelok Solution for Hydrogen seminar. Today we will cover some safety issues around the hydrogen, and we will record this meeting. And everybody in the teams, you are muted, so you can't ask anything in loud. But if you have something to ask, please put it into the chat. And if you have some questions in here at live, we will collect all those questions and answers so that we will send you an email about those, and everybody will get it. But very welcome. Technical issues. All right. So our agenda today will be, I will talk about some couple of words about the Swagelok Helsinki, and concentrate how we can support you with the hydrogen safety and the hydrogen risk, and how you will get your system better around the hydrogen. I will talk about the hydrogen pressure classes, because I will cover some details about the dispensers and the refueling side of the vehicles, and talk about the hydrogen materials a lot. What kind of materials we should consider when we are dealing with the hydrogen. And the last but not least, hydrogen grab sampling, how we should take a hydrogen sampling from the dispenser. But first of all, Swagelok journey starts from the 76 years ago. Fred Lennon started this business with a small loan, and the idea was to design easy to install leak tight tube fitting, and make the best product possible to help customer to succeed and keep making it better. That was the golden sentence what drives us to forward. But 76 years ago, when this starts. Shortly about Swagelok. Nowadays it's around a little bit over $2 billion annual revenue company, private company. We have 22 manufacturing facilities, mainly in the States. We are doing business with 70 countries through the around 200 sales and service centers. This is a famous sales and service center where we are right now. And we have around 9,000 people. Corporate side, we have around 6,000 people right now, and the sales and service centers covers like something like 4,000 people in there. Shortly about the Swagelok. Our cores and values drive us forward. Our vision is to be the fluid system expert the world relies on, and our mission, like it says in there, apply our collective talents with understanding and passion to improve each day. And every Swagelok associate, me included, we really strive to live by these core values: customer focus, integrity, quality. That's very important thing. Continuous improvement. We try to improve ourselves and respect each other and try to be innovational. Swagelok serves more than 30 individual markets around the globe, but for us, chemical, petrochemical, oil and gas, semiconductor, and especially clean energy is very important for Swagelok Helsinki. And couple slides about Swagelok Helsinki. Our legal name is Helsinki Valvet Fitting Oy, and we are independent Finnish company, and operates Swagelok exclusively sales and service center in Finland and Baltic countries. We have now 40 years experience, and our 25 people will more than happy to help your hydrogen system challenges, whatever you have. So our headquarters is here in Vantaa, warehouse is here also, and production, what we're doing happening this place, and we are situated in Vantaa. And like I said earlier, we are also covering the Baltic countries, so we have an office in Tallinn, Riga, and Vilnius, and every those towns have a own sales representative in their sales guy. And last year turnover was a little bit under 9 million euros. Swagelok focus area for clean energy market, as well as how we able to support our customers. So, like I say, we have Swagelok have a 76 years experience about the fluid systems, and all that 76 years we have been dealing with working with the hydrogen. So hydrogen it's not so new for us, but the clean energy focus, what you see in the screen right now is how we have divided different sections. So around 3 years ago, Swagelok done market research with the third party company, and they find out that there is a production, distribution, refueling, and mobility. Those are the main areas where we want to dealing with. And the production means the electrolyzers are generally hydrogen production. Distribution is covering pipelines, infrastructure, instrumentation, microgrids, and so on. And refueling is, of course, virtual pipelines, but refueling station dispensers and whatever need to be around there. And mobility is mainly for heavy-duty vehicles like trucks and rail applications. How we can help with particularly with the hydrogen. Like I said earlier, we have a Swagelok company, and we have a sales and service centers in over 200 locations. We have over 9,000 people, and 300 about those 9,000 people. There is more than 300 engineers and scientists, and 100 are dedicated for clean energy, for hydrogen particularly. And then we have 60 plus people clean energy specialist team, which includes the field engineering, application engineering, and some technical specialists who are educated for hydrogen, particularly by Swagelok. Along with our associate network, Swagelok products are integral to success with the clean energy market. So we have identified a wide range of critical components of what we can use with the clean energy, both low and the high pressure hydrogen applications. From fittings, we can see in here, fittings to valves, different kind of valves, hoses, regulators, medium and high pressure products, like FK series fittings especially. Well, I will a little bit talk about more about the FK. And our metallurgists and material scientists understand really the role of the stainless steel and the elastomeric components, how they are playing around the reliable system operation, and working to continuously improve our product range daily basis. To enhance our market-focused product basket, we have our Swagelok have signed some licensing agreements with different companies like VE example. They have a license to do the filling nozzles with the Swagelok tube fitting body, and OMB is one of the producer for those same kind of filling nozzles and regulators and other products, and they have a license to do manufacture FK series end connections for 700 bar. And then we have also Swagelok have an ISO committee representative through the CSA by our principal engineer Chuck Hayes, and he is a member of the NGVA Europe and so on. So we have a representative for those certification and standard companies. All right. Some application solutions for hydrogen, especially what Swagelok can offer for a production size, which is electrolyzers and generally hydrogen generators. Usually those are kind of low pressure systems up to the 30 bar. Temperature can be up to 200 Celsius. Materials are usually 316 stainless steel, but if we have an oxygen or lye system, then we should use the mono as a material for tubing. So, and it can be grab sampling, gas distribution, pressure controls example. For distribution side, those will be the pipelines, infrastructures, and instrumentation around those, storage tanks, microgrids, and of course there might be fuel cells also. In there, stainless steel is fine. That's very suitable material in there. Our product lines is up to the 2 inches, so tube size can be up to the 2 inch. Usually the pressures are, if it's a low pressure version, it's up to 100 bar, and high pressure might go up to the 500 bar. Refueling means virtual pipelines, refueling station, and in there we can see pressures high as 1000 bar. Usually it's a 1000 bar. I will later talk about the hydrogen pressure classes, and there we are talking about the 350 bar, 700 bar systems. And the mobility means heavy duty vehicles. And with the vehicles, the low pressure is 30 bar when we are talking about the fuel cells, what's inside the vehicle, and the high pressure means the compressed hydrogen storage system, and then there it might be 350 bar or 700 bar. And our clean energy engineering team is also able to provide services such as training, system design, and on-site fluid system evaluation advice. Just a few examples of the Swagelok solutions, what we have provided and what we can do here locally in Vantaa example. So example for electrolyzer, analyzer panels. When you produce hydrogen, you need to making sure that the quality of the hydrogen is good enough. So analyzer panel is something what you will need in there. With the virtual pipeline switching, different kind of switching panels, priority panels, and for fueling and compressor systems, and graph sampling is something I will cover. ASTM standard graph sampling system, what we have in here one time, what we can show you to you, and as well as refueling and defueling panels for heavy duty vehicles. This is something what we have already done. All right. The hydrogen, it's a kind of unique thing in our world. It's 14 times lighter than air, and if it leaks, it rapidly goes up. So hydrogen don't stay there where the leaks happens. It goes up, and that's the good thing, because that lower the risk of ignition if the hydrogen leaks. But critical consideration are the leak tightening of the tube fitting or connections. So if there is a leakage, it's always the risk. And if we are talking about the dispensers or refueling stations, the end user are the most critical part in there. We are the risk in that case. And when we think about leak tighten fittings, we need to also think about the efficiency, and we like to use all that hydrogen what we have produced, because hydrogen producing is very expensive. And so hydrogen can escape very easily. But one very important thing with the material side is the hydrogen embrittlement. Gosh, difficult word. And that means that the hydrogen molecules, hydrogen ions, will go inside to the example stainless steel, and with the pressure and the time, they can produce cracking on fissures, or make some bad things for a material. And stainless steel is it's a very critical with that. And when we are dealing with the hydrogen, we need to consider the oxygen also, and we have some unique thing with the oxygen. It's a most abundant element in the nature. About 21% of our breathing air is oxygen, and oxygen is slightly heavier than air. It's not, we can't taste it, smell it, see it anyhow. Oxygen is not, it's not the fuel. It will not ignite, but it's a strong oxidizer. And if we have a oxygen in present, everything basically burns, even stainless steel burns, and that's the risk of the oxygen systems. So that when we think about the safety, the material selection is very important, and the cleanliness of the whole system, cleanliness of the installation, how that have been done. It's very critical for our safety when we think about the safety of the oxygen service. So for oxygen service materials, Monel, brass, Hastelloy, those are the stainless steel materials what we should consider in there. If the oxygen level goes up to the 23%, then the environment it will be oxygen enriched, and everything start to burn much more faster. And so what we should do with the oxygen is maximize the compatible materials in used, minimize any ignition mechanism what might happen in there. We need to minimize all particles in the tubing, and utilize the best safety practice what we can find. And when we combine hydrogen and the oxygen, we think about the hydrogen side. There is a unique molecular properties what hydrogen have: very low ignition energy and wide flammable range. And if we think about the oxygen side, all materials become more flammable. Ignition mechanisms become more active in the oxygen with the oxygen, and if we have a fire, the fire will be more severe. And this is some comparison with the methane and the gasoline example. So hydrogen with the air, it will burn like 4% of 75%, and if you have a hydrogen in the air in those limits, it will burn. And if we have a hydrogen with the air 18 to 59%, it will explode. So it will be much more stronger burning functioning. So with the oxygen levels, when we think about oxygen, we always need that oxidizer fuel and ignition energy when we build a fire. And system design, component selection, material and of course construction, fabrication methods, those are the key things to with safety systems. And with the Swagelok, we have different kind of different cleanliness specifications, and SC11 is for oxygen services. So if you start to discuss with us about any kind of systems and you have oxygen, then we automatically start to think about these cleanliness levels. So the fluid hydrogen system can leak because of the many reasons. The sealing area is bad. Hydrogen can permeate through the materials, and or we have a bad designing of the system, and really unfortunately not all solutions are created equally, and that's the one of the things why we see the leakage, and that of course the safety factor when we're dealing with the hydrogen. So the permeation is one thing with the hydrogen, and this there's two different mechanisms. Interstitial mechanism is one, and substitutional mechanism is one, and the main thing is that the hydrogen will divide to the two hydrogen ions, and the hydrogen ion will go through the thin metal, example diaphragm, with these two different mechanisms. How to create this proper sealing? That's the main thing when we think about tube fittings or valves. So all machine surface, they have a some degree of roughness. There's peaks and valleys, and those are the leak paths that we need to somehow avoid. And with the Swagelok tube fitting example, we will create sealing area during the installation. So those ferrules inside the Swagelok tube fitting example, they will create the sealing area in there. And if we talk about the valves, usually we have some plastic or elastomer for sealing purpose, and usually we use also some grease to create the sealing in valves. And roughly we can calculate it. We can calculate how much the leakage might be. This is something what we can go through during our tube fitting installation training example, what this formula means. But roughly we can calculate the whole total of the leaks. Okay, and then some hydrogen pressure classes, particularly for vehicles and the stations. So there is a standard, and we have a pressure classes according to this standard. And when we talk about the standard, it's like set in the stone, so we should not change it. If we are engineers or we are designing systems, we should not add any safety factors for these pressure classes, because everything is considered already in an ISO standard. Some terms what you might see with these classes are that everything is in megapascals. So we are talking about example 70 megapascals. That means 700 bar. Nominal working pressure, it will be at 16 Celsius ambient temperature. Then there is a maximum operating pressure, maximum allowable working pressure, and then there is a test pressure, integrity test pressure. And all temperatures are range from minus 40 to the plus 85. And the reason for that temperature range is vehicle cylinders, those storage tanks. They can handle maximum the plus 85 Celsius temperature. That's the maximum temperature for those cylinders. And one thing what we should remember always with the hydrogen, there is a reverse Joule-Thomson effect. So when we add the hydrogen into the empty cylinder, it will heat up. It will not freeze like another ideal gases. So it's a opposite way. So some examples are maximum allowable working pressure for vehicle. In this case, we have an example 700 bar system. The maximum allowable working pressure will be 875 bars. And if you think about it station-wise, the dispenser, and what's the maximum allowable working pressure in here, 700 bar system, the pressure relief valve will be set it as up to the 962 bars. So we are a little bit under 1000 bar. And With all systems, we need to do some testing. And for dispensers example, the maximum test pressure will be 1050 bar in this case. So it's over 1000 bar system. If you are seeing the hydrogen refilling stations or hydrogen car, so it will be the almost 1000 bar system. So there's an example from the ISO standard and what pressures we will see in here. So nominal working pressure 700 bar, maximum operating pressure 875 bar, and maximum allowable working pressure 962.55 bar actually, and the test pressure will be 1050 bar. About the material side, talk about the stainless steel, Swagelok stainless steel. Main components with iron are nickel and chromium and molybdenum. Nickel is for a stabilizer, for crystal structure of the steel. Chromium and molybdenum will be because of the corrosion resistance. And ASTM standard says that when we are talking about the 316 stainless steel, the nickel content need to be 10 to 14%, and the chromium content will be 16 to 18%. And Swagelok have decided years and years ago that nickel content need to be 12% and chromium content need to be 16%. In that way, our Swagelok material will be much more corrosion resistant than other 316 materials. And one thing about the Swagelok material, it's unique. You can't purchase it anywhere else. When Swagelok purchase material for tube fittings or valves, they will purchase the whole batch of stainless steel with these unique characteristics. So there need to be nickel and chromium content on that certain level what Swagelok have decided to use. And that nickel content is very competing for a hydrogen embrittlement. So when we have a 12% nickel content in stainless steel, it will be much more embrittlement resistant material, and that helps for embrittlement. Because every time when we're talking about the stainless steel in any grade, there is an embrittlement possibility that happens. It takes time and pressure, but it happens. But with the certain nickel content, we can avoid it as much as possible. When we talk about the good tube fitting, good high quality tube fittings, we need to think about the tube grip, gas seal, vibration resistant, and Swagelok robust tube fitting design delivers all those three functions for tube fitting. Tube grip, which happens in back ferrule. With the back ferrule, there is a hinging and collection action, and that contact provides the great content and gripping action to support the tube and keep the tube inside of the fitting. Gas seal happens in a front ferrule, between front ferrule and the fitting body, front ferrule and the tube, and we call it burnishing and polishing action, which happens in there. So there's those peak and valleys because of the machining of the ferrules or tube fitting, and all those will be polished away and create the sealing area. And the back ferrule also taking care of the vibration resistant, so the robust grip for a tube helps the vibration with the vibrations. And with the back ferrule we have that hinging and collection action which means that the back ferrule shapes a little bit when we pull this fitting together, and there is a patented carburization process. This is actually in the next slide. And in here, Swagelok have a unique low temperature carburization process where we get the very hard surface over the back ferrule, but at the same time, even this is a the surface is very hard. The inside of the ferrule, the material is the same. It's a 316L, and that means that we will not sacrifice any corrosion resistant, but the material is very ductile, so it's non-brittle. It will not crack during the installation. If somebody think about what are these dots in here, small dots, those are the marks of the hardness test. So we have tested how hard the material in there is. Right. Then about the technologies, what we use right now and what we should use with the hydrogen. Starting with the fitting. Nowadays, very common way to do the high pressure systems are the cone and thread fittings, where we have a tube, then there is a thread on the tube, and then the now I collar over the tube, and then we use the nut to press the tube against the sealing area, which is more make it into the tube and the between the fitting body. But when we do the cone and thread installations, there is no any international standards for cone thread fittings. The cones and bodies, the degree of the cone varies from the 57 to the 63 degrees. If there is any, misalignment, then it's very easily leaks. When we do the coning, usually on a field with the hand tools, and so that we can get this fitting to the leak free, it requires some grease to create the sealing area. And new approach from the Swagelok side is a FK series fitting technology, which is designed for hydrogen, reliable leak tight installation and reassembly possibilities. So it's designed for small molecule applications. It's vibration resistant, very robust tube grip, and very easy to install. We can use the cold drawn hard tubing and lead tubing, and pressure ratings from the vacuum up to the 1,378 bars. So it's a 20,000 psi. Temperature range -50 up to the 500 C. The tube sizes up to the 1 inch. 1 inch means OD of the tube 25.4 millimeters, and it's certified for those hydrogen applications like H35 example, H40, H70 vehicle applications. Whenever we use the FK fittings, it's around 5 times faster to install than common thread fittings. Requires only common tools, just a hacksaw and the normal tools. Of course, need to be trained how to install it correct way, but it's very easy. And Swagelok have done like over 1,000 connections with this fitting, and those are leak free, and particularly for hydrogen applications. And so we have a lot of data how leak free it is. This fitting is. About the test reports, Swagelok have a laboratory where we can do the different kind of, for example, corrosion resistant test, vibration, hydrostatic pressure testing, and of course the approval testing for a different kind of for different kind of approvals, like a ISO standard or whatever need to be done. Right, then about the hydrogen crab sampling, what it means. Unfortunately, in Finland we don't have any hydrogen dispensers. I know that in Estonia there will be at least 2 in a couple of years, but it's coming. So this is like a future, watching in a future. So when we have a hydrogen car, we have a fuel cell in there, then we have a hydrogen tank, and there is an ISO standard for how what are the quality requirements for hydrogen that fuel cell will works as it designed to work. And hydrogen purity generally will be around 5.0 level. So it's that's the grade of the hydrogen. And when we talk about the hydrogen dispensers or refueling stations, we need to do some testing in there, and there's some standards and equipments how to do it. This hydrogen station test apparatus, which imitate the hydrogen car, and that test will taking care of the all temperatures and pressures that those are set it currently accordingly for the vehicle itself. Then we need to take some crab sampling and particle testing, that we just make sure that the hydrogen quality is good enough for vehicles. And then mass transfer measurements, which are kind of refueling station calibration purposes. All right. When we take a crab sampling, crab sampling means taking sample in a cylinder and then bring it to the laboratory. The parts what we find out from the hydrogen crab sampling, you will find the water, hydrocarbons, oxygen, helium, nitrogen, different kind of gases in there. But all hydrocarbons are the most critical things for a fuel cell. So if there is too much hydrocarbons, it will damage the fuel cell. And some contamination which need to be think about is nitrogen loss, because nitrogen is used for purging systems. When we need to purge the hydrogen out from the from the system, we usually use nitrogen for that. And if we have a nitrogen contamination, it might affect the efficiency of the hydrogen fuel cell. When we take a sample, you might get some old samples in there. The nitrogen contamination is already here. There might be permeation, or if there is leakage in a fitting example, that might destroy the sample. But how to take a sample? The idea is take a sample very near to the filling nozzle. That's the place where we should have a high quality hydrogen for a car, and that can be done with this kind of parallel method. We have a T-fitting in here between the nozzle and the car, and then we just fill the car and take a branch line and put it in a cylinder and bring the sample into the laboratory. Another thing is put it in serial. So we just get the cylinder and fill the cylinder directly from the dispenser. But when we do any kind of testing or trap sampling, we always need to consider safety. And one thing what have been considered is one standard where this safety have been considered is the ASTM standard. And in here we have some pictures how the sample is taking from the system or dispenser. And Swagelok we have manufactured this kind of panel according to this ASTM standard. And what happening here, we take a sample from the nozzle. We get the sample into the sample cylinder, and then there is also the vent line, which makes sure that the sample taking is as safety as possible. And using Swagelok FK fittings and Swagelok products in here, it will be leak free, and of course we have tested and so on, leak tested, and it's safe. Then the Swagelok have a engineering part of the Swagelok, includes field engineers, application engineers, technical specialists, and these are the group which can help you about the evaluations, assist the designing, helping improve efficiency. And example, we have here in Vantaa, we have three field engineers, one application engineer, and one technical specialist in house. So we have a wide range of the engineers to help you with any solutions. Overview about the Swagelok Field Engineering Services, what we can offer: fluid system evaluation, commissioning service. We can do the leak detection for gas systems, hose advisory service. You can come to the site and check your hoses, how you have done it, and then sampling system evaluation. Just an example. So about the commissioning service, like it says in here, fluid system requires fit for application. It is used in to offer the reliable and safety installations. I think everything is in one sentence. So we can help the find out the leakage points example during the installations, and that how prevent any loss of the money. We can help to increase the system cycle life, reduce the maintenance, find out the correct materials, and from that way, safety is a important thing. Some examples about the services what we have done for hydrogen applications. So technical engineering team, we have a different kind of applications tools what we can use. We can do the line sizing calculations. Think about the economical side for the solutions. Find out the correct line sizing during that, and find the cost savings. And when we talk about the hydrogen, it's not just a hydrogen line. We should also consider the vent lines, because we need to. There's always the chance that we need to, purge the line, and we need to put the send the hydrogen some safe place with the vent lines. When we dealing with the hydrogen, do any testing or evaluations, we use the thermal imaging cameras, because if hydrogen burn, we cannot see the flame. So the thermal imaging camera is the only way to find out the burning hydrogen. In the daylight, you can't see it. Then we use the ultrasonic sonic detection equipments, and then some sniffers for hydrogen application, which is a right side thing in here. And this is something what we can use also for leak testing. Any our installations. One of our examples how we dealing with our online tools. This is regulator sizing tool, what you can find from the swagelok.com. So we can size the regulator correct way. We also need to consider the Joule-Thomson effect. We have a calculator for that also. And finally, we have a solution for a customer where we have a first state regulator in here, and then second stage regulator is here. And the whole idea in here is to produce send the hydrogen into the process line from the 200 bar cylinders and reduce the pressure down to the 12 bar, and nominal need in a cubic meters will be 7,400 cubic meters hydrogen through this system. And one way how we can help with the engineering team is that you have a hand drawing, like here in the left side, and from the hand drawing, together with our customer, we can build up the PNI drawing, and from the PNI drawing, we can build a 3D model, and then build the whole panel together and test it, and whatever it needs. And then we go to the our fabrication service. We call it custom solution. So this means that we fabricate any kind of systems. We do the CAD drawings from those PNI drawings, like I said earlier. We have selected the right components in there, and then to the installation, to the testing, and then pack it correctly, deliver it to the any site where it needed. When we talk about the safety, the education, and the training, that's I believe the key function in there, and that's something what we do here in Vantaa. We provide the Swagelok essentials trainings about how to install tube fitting, how to install FK series fittings, how to select ball valves, how to select valves generally, and then we can provide the Swagelok corporate site trainings like process analysis sampling system training, or brand new training for a hydrogen service, which is like a 2 days training, particularly concentrating about the hydrogen systems, where we go through the hydrogen awareness and tube fitting installation, inspection, things like that. But this is coming. This is not yet in our service what we can offer, but it's coming. And unrivaled product quality. So our products very high quality, and the Swagelok quality system to help us to provide this high quality production, high quality service. We have a high quality products from the Swagelok, but the quality system itself, what we follow in here in Vantaa, help us to provide high quality systems and high quality services for a customer. And of course, we can't skip the Swagelok lifetime warranty what we have, which cover all the products and services what we do in our sales and service center, or with the Swagelok general. All right. I think my time's I'm done in here, and thank you very much. If there's any questions in a chat, we will answer those questions. If you have now any questions in here in live, and try to answer it if it's possible. But
so you have access to all the engineering capacity in the corporation.
I'm sorry.
Engineering capacity. You have access from Finland to all the engineering.
Yes. And we have those engineering capabilities here in Finland also. Like I said, we have a field engineers, application engineers, technical specialist here in Vantaa, and we can provide design services. We can choose the right components. We can help with the design. That's what we're doing here.
Your greatest achievement in the field of hydrogen, as a firma, I mean,
as a Swagelok Helsinki, or as a whole Swagelok. Yeah, in here in Finland, I think biggest achievement nowadays is give this information to the customers. We are participating in a hydrogen cluster in Finland. We have been trained, and we will train the people about the hydrogen systems, and that's our biggest approach right now. Of course, we are working with different kind of projects what we have in the Baltic area and Finland. but those are kind of there are design phase or how to say it. They are not there. There's no money yet in the project, and we are waiting. That our customers are waiting the money for projects. So we are more or less helping with the designing and the training to the people how to deal with the hydrogen and how to do the leak tight connections. You know, that's the biggest achievement. Maybe, I don't know, Pekka might have some other thoughts as a company leader.
Yeah, I could maybe sorry. I could maybe add on. So I will.
Please.
Yes, so I would add on Sami's comment that I think one of the biggest achievements we have now as Swagelok, but also Swagelok Helsinki, is the new approach that we're not only focusing on the products, we're focusing on understanding the total solutions. And we have this engineering services approach where Sami, for example, is a Swagelok trained application engineer with the clean energy focus. So from there, we can bring together our global talent and knowledge, which we have already been for many years, 40 years here in Swagelok Helsinki, and 75 years for Swagelok. The understanding of hydrogen and now delivering that understanding back to the customers. You were able to see during the presentation a few examples what we have already done here locally, but many of the applications that we are working are global projects. Norway, Sweden, Denmark, for example, Netherlands, Germany, very advanced on the solutions on electrolyzers, refueling systems, compressor systems, and so. But we can bring that knowledge back to you through our network. I think that's the biggest achievement. And we are just on early stages. As you saw, Swagelok is developing new customer-facing trainings. We are training ourselves, and hopefully we can then give something back to you guys as then when whatever projects you have that will bring more safe systems for you, and then from there a greener solutions for the global use. That was a long answer. Sorry for that. You're welcome. And I think we have now passed the. I'm not seeing any questions coming through the chat or Q&A system. There was a comment in a Q&A from Riga that they have a refueling station up and running in Riga. So please take a look on the link also on the Q&A session. We will stop the recording right now, and I think this will conclude the webinar. The live meeting will continue here in Vantaa.
All right. Thank you.
Thank you very much.
Bye-bye.